Hi, this is Bradley Bush. Today we're going to talk about finding the limit of a function algebraically. So the first thing that you generally should try when finding a limit algebraically is to plug in the c value. Because if you plug it in and the result is a real number, meaning you actually get something, it works out and it isn't something like 0 over 0, then you're done and you found the actual limit. So if we plug in 2, because 2 is our c value in our case, then we're going to take our function and we're going to plug in the c value of 2. So we have 2 squared plus 32 all under the square root minus 6, and in the bottom, instead of x, we're going to plug in 2. When we do some algebra, we have 2 squared gives us 4 plus 32 is 36. The square root of 36 is 6, and so over here we end up having 6 minus 6, and in the bottom 2 minus 2, they both give us 0. So we have 0 over 0. 0 over 0 is called indeterminate because when you have a limit, you're actually taking the limit of the numerator, 0, and the denominator. You have the limit of two separate functions that are both competing to get to 0, and you don't know which one will win, meaning you don't know which one will get to 0 first. So if the numerator, the limit, goes to 0 first, then you have 0 over something in the bottom, which ends up being 0. But if the limit in the denominator wins, if that goes to 0 first, then the whole quantity could blow up and you could have infinity. So we don't really know what it is, and because we don't know what it is, we call it indeterminate. So if we get 0 over 0, then we need to try some algebra. Notice the issue, having 0 as a limit is perfectly fine, but having 0 over 0 is a problem. So the real issue here is this 0 in the bottom, and that comes from the x minus 2. So if we can do some algebra to get rid of the x minus 2, then maybe we can make some progress. So let's try. A little hint, because we have a radical, let's try to rationalize the numerator. So rationalizing the numerator means multiplying on top and bottom. So in other words, you're just multiplying by 1. This quantity right here is equal to 1, but it's a special kind of 1. It's something that will, when multiplied by the top, the numerator of our function, it'll get rid of the radicals. So if you notice, what we have in the numerator and the denominator is the same. So this right here is actually identical to this, except for one thing. And that one thing is the sign right here. Those change. It started negative and we make it positive. And then what we multiply there in the top, we also do in the bottom. So we are indeed multiplying by 1. Once we do the algebra, meaning once we multiply what we have here in the numerator, which is a foiling problem, we get the square roots multiplied by each other, which gets rid of the square roots. We have a negative 6 times the square root of x plus 32 and a positive 1. Those cancel out. And then negative 6 times 6 gives us 36. So we get that in the numerator. In the bottom, we still have the root x squared plus 32 plus 6 multiplied by the x minus 2. We're going to leave it like that. We're not going to multiply it through because our hope is that this right here will cancel. Again, our hope is we hope this will cancel. So x squared plus 32 minus 36 actually gives us x squared minus 4. And we recognize that as the difference of squares, and we can factor it into x minus 2 and x plus 2. And once we do that, we see right away that we've got some good things going, because these x minus 2's can cancel, and we've just gotten rid of the problem. Remember, the issue we had was this right here, the x minus 2, and now we no longer have it. So we just have x plus 2 in the top, and then the square root of x squared plus 32 plus 6. So now we've gotten rid of the problem factor. Let's try to plug in x equals 2 again. So if we plug in 2 in the numerator, we plug in 2 down here in the denominator. 2 plus 2 in the numerator gives us 4. And 2 squared is 4. 4 plus 36, or sorry, that was a Freudian slip. 4 plus 32 is 36, and root 36 is 6. 6 plus 6 is 12. And then our final step, this can be simplified to 1/3. So this limit then, the limit of the square root of x squared plus 32 minus 6 all over x minus 2 as x approaches 2 is actually equal to 1/3. Thanks for watching. If you'd like, please leave comments and like the video. Thanks.